Hi guys, I'm back with my lecture. This is Mr. Joseph, your chemistry teacher. So today, in today's lecture is a continuation of our previous lecture on lattice energy. We're still on lattice energy, and today we'll be looking at ion polarization. We'll be looking at what is polarization. We'll be talking about polarizing power and factors affecting ion polarization. So please, I want us to listen attentively and get the best out of today's lecture. So we're looking at ion polarization. When we talk about ion polarization, it occurs when the positive charge on the cation in an ionic lattice attracts electron in the anion towards itself, which results in a distortion of the electron cloud of the anion, and the anion is no longer spherical. It distorts the shape of the anion. So we call this distortion ion polarization. Let's take, for example, this an ionic compound, which is XCO3 which is a carbonate, and it's an ionic compound. Ionic compound that consists of what? Aggregate of what? Oppositely charged ion, positive and negatively charged ion. So this is X2 plus, and this is CO3 2 minus. So this is the positively charged ion. I just use X to represent, and this is what is a carbonate, a negatively charged ion, which is what? A compound ion, a radical, which are group of atoms with charges, or we call it compound ion or complex ion. So in ion polarization, what happens is that the cation, which is the positively charged ion, attracts electron from the carbonate ion. As it attracts electron, it distorts the carbonate ion. It stretches the carbonate ion and weakens the carbon oxygen bond. Weaken the carbon oxygen bond, so that the compound can easily decompose. Like in the case of this compound, what happens is that it distorts the anion, it weakens the carbon oxygen bond, so that the compound can easily decompose to XO, which is an oxide of the positively charged ion, and carbon dioxide. So that process is what we call ion polarization. So if the cation is highly charged, it will distort the anion to a greater extent, so that the bond between the carbon and the oxygen, the bond in between the carbon and the oxygen is weakened. It stretches it, so it distorts the anion. So that distortion is what we call ion polarization. So the compound can easily decompose. It can easily decompose, break down to its oxide and carbon dioxide. An oxide of the compound, which is XO. If it is calcium carbonate, it can easily decompose to calcium oxide, which is an oxide of the metal, and carbon dioxide. So the ability of a cation to attract electron and distort an anion is what we call the polarizing power of the cation. So it's as simple as A, B, C. So having considered ion polarization, we want to look at factors affecting ion polarization. Now, the degree of polarization of an anion depends on the charge density of the cation and the ease with which the anion can be polarized. So we'll talk about ion polarization, that it occurs when a cation attracts electron from an anion and distort the anion. So that distortion process is what we call ion polarization. So an anion is more likely to be polarized if the cation is small and the anion is large. So the two major factors is the charge density of the cation and the ease with which the anion can be polarized. So an anion is more likely to be polarized if the cation is small and the anion is large. So we're talking about the size of the cation, or we'll call it ionic radius. The size of the cation affects the degree to which an anion can be polarized. The smaller the size of the cation or the ionic radius, the smaller the ionic radius, the smaller the size of the cation, the higher the charge density, the higher the polarizing power. When we talk about polarizing power, is the ability of a cation to attract electron to itself and distort an anion. So that ability is what we call what? Polarizing power of that cation. So the ability of a cation to attract electron and distort what? An anion. So that process what we call what? The polarizing power of what? The cation. So the smaller the size of the cation, the higher the charge density, the higher the polarizing power. The larger the size of the cation, or the larger the ionic radius, the lower the charge density, the lower what? The polarizing power. So if an anion is highly polarized, that means it's highly distorted. The bonds in between them is weakened, and it can easily be broken down. So a cation that is small and highly charged will have the greatest polarizing power, while a cation that is high and less charged will have the least polarizing power. So these are the factors that affect ion polarization. The smaller the size of the cation, the higher the charge density, the higher the polarizing power. The larger the size of the cation, the lower the charge density, the lower the polarizing power. So I want to look at the thermal stability of group 2 carbonates, the effect of ion polarization on the thermal stability of group 2 carbonate. Group 2 carbonate, they decompose it to their oxides and carbon dioxide on what? On heating. This is calcium carbonate, for example, when it decomposed of calcium oxide and what? Carbon dioxide. So we want to see the effect of ion polarization on the thermal stability of the group 2 carbonates on their decomposition temperature. Now these are group 2 carbonates. We have magnesium carbonate, MgCO3, 2 plus, CO3, 2 minus, calcium carbonate, 2 minus, 2 plus, strontium carbonate, 2 plus, CO3, 2 minus, barium carbonate, 2 plus, CO3, 2 minus. So as you go down the group, what happens is that the size of the cation increases. That means the charge density decreases, and the polarizing power also decreases. That means magnesium carbonate is highly polarized. That means magnesium carbonate can easily decompose. Magnesium carbonate can decompose to its oxide and carbon dioxide at a lower temperature compared to calcium carbonate, compared to strontium carbonate, and compared to barium carbonate. That means barium carbonate is the least polarized. So it will be very difficult for it to decompose. So the thermal stability will get higher. As you go down, the thermal stability increases down the group. The decomposition temperature increases as you go down the group. So barium carbonate can be decomposed with the highest temperature because it's the least polarized. Because as you go down the group, the size of the cation increases, the charge density decreases, the polarizing power also decreases. So magnesium carbonate is the most polarized, and barium carbonate is the least polarized. So barium carbonate has the highest decomposition temperature and is more thermally stable, while magnesium carbonate have the highest decomposition temperature and is the least thermally stable. So you can see the decomposition temperature of barium carbonate is greater than the decomposition temperature of strontium carbonate. Strontium carbonate is greater than calcium carbonate. Calcium carbonate is greater than magnesium carbonate. So that is the effect of ion polarization on the thermal stability of group 2 carbonate. So magnesium carbonate is the most polarized. It has been stretched. The carbon oxygen bond have been stretched. So you just need a very low temperature to break it down to magnesium oxide and carbon dioxide. So if you look at what we have here, the further down the group, the higher the temperature required to decompose the carbonates. So the thermal stability increases down the group. So as you go down the group, what happens? The ionic radius increases, the charge density decreases, the polarizing power decreases, meaning they become less polarized, and the thermal stability and decomposition temperature increases as you go downward as you go down the group. So you can see it's as easy as what? As A, B, C. So for the thermal stability of the group 2 nitrates, a similar pattern is observed with the thermal decomposition of the group 2 nitrates. But the difference is that this decomposes to what? To form the oxide, nitrogen dioxide, and what? And oxygen. So when the nitrates of group 2, when they decompose, they will form the oxide of the compound, they will form nitrogen oxide, which is a brown gas, and they will form what? Oxygen. So as you go down the group, magnesium nitrate, NO3 minus, calcium nitrate, NO3, strontium nitrate, and barium nitrate. Now what happens is that as you go down the group, the ionic size increase as you go down the group. So the charge density will decrease and the polarizing power will decrease also. So barium nitrate is least polarized compared to what? Magnesium nitrate, calcium nitrate, or strontium nitrate. So the most polarized is what? Magnesium nitrate. While the least polarized is what? Is barium nitrate. So the order of stability with respect to the product in this order, barium nitrate is more thermally stable than strontium nitrate. Strontium nitrate is more thermally stable than calcium nitrate. Calcium nitrate is more thermally stable than what? Magnesium nitrate. So magnesium nitrate will have the least, decomposition temperature, while barium nitrate will have the highest decomposition temperature as a result of the extent to which they are being polarized. So it's as simple as ABC, just similar pattern. But when nitrate of group 2 decompose, they'll form two oxides, which are nitrogen dioxide or nitrogen oxide, which is a brown gas, and oxygen gas, which is a colorless gas. So it's the same pattern, it's similar pattern that occurs between thermal decomposition of the carbonates of group 2 and the thermal decomposition of the nitrates of group 2. So thank you very much for listening. I'm Mr. Joe, your chemistry teacher. Please subscribe to my YouTube channel. Go to the comment section and give your feedback. Feel free to reach out to me if you encounter any difficulty while going through the video. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Mr. Joe, your chemistry teacher. Thank you.